and every complex number is of the form a plus ib. Conjugate over z1 minus z2 will be equal to conjugate of z1 minus conjugate of z2. If mod of z, if mod of that complex number is equal to... Dear students, welcome to Allen Overseas. Let's continue with our special series. This series will cover 45 important topics in 45 days. It will be really helpful and important for the JEE Mains aspirants. This is how the topics and the subjects in the series are divided among physics, chemistry and mathematics. And I am going to take mathematics for you all. So let's start. Today we are going to discuss about a concept called conjugate of complex number, which comes from the chapter complex number. So what is a complex number? Before starting on the conjugate, complex number is just those numbers which cannot be represented on the real number line. Just like we represent real numbers, they are represented on imaginary number line or imaginary number plane. And generally every complex number is of the form a plus ib. When I am writing z equals a plus ib, z represents a complex number. Z is the symbol which we use to represent a complex number, and every complex number is of the form a plus ib. Here a is the real part, a will be a real part, it will be a real number, and ib is the complex or imaginary part, where I stands for iota, means square root of -1. This number, square root of -1, this is called iota, and on this number only entire complex number theory is based. Now what is the conjugate of a complex number? Conjugate of a complex number, if I am representing z, which is a plus ib on the number plane, if I want to represent z, z is equal to a plus ib, then its conjugate will be the image of z in the real axis. So what will be the image? Image will be a minus ib. Right? So if I'm talking about a complex number z which is equal to 3 plus 2i, then its conjugate, which will be represented by z bar. Here also the conjugate will be represented by z bar. We represent the conjugate by a bar over z. Z bar means the conjugate of z, which will be 3 minus 2i in this case. Now some properties based on conjugate. Before that, let's look at some properties of modulus also. So mod of z, modulus of z means if z is equal to x plus iy, then mod of z is equal to square root of x square plus y square. And we know square root is always greater than 0, greater than or equal to 0. So mod of z will always be greater than or equal to 0. Mod of z will be equal to mod of conjugate of z and also equal to mod of negative of z. Z multiplied with its conjugate. Suppose we are multiplying a number with its conjugate, it will always result into square of mod of z. For example, if my complex number is x plus iy, its conjugate will be x minus iy. And this will result in square root of x square plus y square whole square, which is mod of z only. So complex number multiplied with its conjugate result in square of the mod of that complex number. Mod of z1 into z2 can also be written as mod of z1 multiplied with mod of z2. Mod of z1 divided by z2 can be written as mod of z1 divided by mod of z2. Condition is z2 should not be equal to 0. The denominator should not be equal to 0. If we apply mod on z to the power n, that is going to be equal to power n applied on mod of z. That means mod of z to the power n is equal to mod z to the power n. Some more properties on conjugate now especially. So if we take the conjugate of a complex number and again we take its conjugate. For example, my complex number, let's say, is 3 plus 4i. Right? Z and its conjugate will be 3 minus 4i. Again, if I find the conjugate of 3 minus 4i, that will again result in the original complex number, which was 3 plus 4i only. Then z plus conjugate of z always result in 2 times the real part of z. if z conjugate is equal to negative of z, this would mean that z is purely imaginary. There will be no real part in z in that case, right? If z conjugate is equal to z, this means that z is purely real, right? This also, we can also say z minus z conjugate is equal to 2 times the imaginary part of z, right? In this case, z plus z conjugate is equal to 2 times the real part of z. So if z conjugate is equal to negative of z, that means z will be purely imaginary. And if z conjugate is equal to z, that means z is purely real. And in this case, z minus z conjugate will be equal to 2 times the imaginary part of z. If we have z mod over, if we are taking the conjugate of z1 plus z2 altogether, we can write it as conjugate of z1 plus conjugate of z2. Same thing applies while subtraction. Conjugate over z1 minus z2 will be equal to conjugate of z1 minus conjugate of z2. Now, if we are multiplying and taking the conjugate, we can do it individually also. Conjugate of z1 multiplied with z2 will be equal to conjugate of z1 multiplied with conjugate of z2. Conjugate of z1 by z2 will be equal to conjugate of z1 divided by conjugate of z2. z1 into z2 conjugate plus z1 conjugate into z2 will always be equal to 2 times the real part of z1 z2 conjugate. And z1 into z2 conjugate minus z1 conjugate into z2 is going to be equal to 2 times the imaginary part of z1 z2 conjugate. Now, let's see some questions based on the properties of conjugate which have appeared in earlier JEE Mains papers. So here is the question. Here they are saying z is equal to root 3 by 2 plus I by 2 to the power 5 plus root 3 by 2 minus I by 2 to the power 5. And if real part of z and imaginary part of z are represented by rz and iz, then which of these condition is true? Then which of the option is true? Now, if we observe carefully at z, z is equal to a complex number plus the conjugate of that complex number. Root 3 by 2 plus I by 2 is a complex number, and root 3 by 2 minus I by 2 will be the conjugate of that complex number. So let me call this complex number z1. So z is equal to z1 plus z1 conjugate. Am I correct? Now, if we want to simply solve very easily or very quickly, we want to solve this question, we can simply say that option C is going to be correct. And why am I saying that? Because z1 plus conjugate of z1 is always going to result in 2 times the real part of z. Right? 2 times the real part of z1. That means z is not going to have any imaginary part. So the imaginary part of z is going to be 0. That's very simple to say. But with the normal procedure also, with another way also, I can prove this, that why imaginary part of z is going to be 0. So we know that my z is equal to root 3 by 2 plus I by 2 to the power of 5 plus root 3 by 2 minus I by 2 to the power of 5. And now I know that root 3 by 2 plus I by 2 can be written as e to the power of I pi by 6 to the power of 5. And this root 3 by 2 minus I by 2 can be written as e to the power of minus I pi by 6 to the power 5. And now I can further write it as e to the power of I 5 pi by 6 plus e to the power of minus I 5 pi by 6. And e to the power of I 5 pi by 6 will be equal to cos 5 pi by 6 plus I sin 5 pi by 6. And this part is going to be equal to cos of 5 pi by 6 minus I sin 5 pi by 6. And now I can simply see that this part and this part is going to be equal to 0. So I'm finally getting 2 cos of 5 pi by 6, which is completely real, right? There is no imaginary part left in the solution now. So this is completely real. I can always say that imaginary part, that means Iz is going to be equal to 0. And what about the real part? Rz is going to be always less than 0 because this part is always less than 0. Cos 5 pi by 6 will always be less than 0. So real part of z is always going to be less than 0 and imaginary part is always going to be equal to 0. So we had marked the correct option to be correct. Now let's look at the next question, which has also appeared in previous year's JEE Mains question papers. And here a complex number z is said to be unimodular. They are giving a new term for a complex number which will be called as unimodular if mod of z, if mod of that complex number is equal to 1. Now suppose z1 and z2 are two complex numbers such that this condition, mod of z1 minus 2z2 divided by 2 minus z1 z2 conjugate is unimodular and z2 is not unimodular, right? z2 is not unimodular. This number is unimodular but z2 is not unimodular. Then the point z1 lies on which of the four options? Now if this thing is unimodular, so I can simply write z1 minus 2z2 divided by 2 minus z1 z2 conjugate, mod of this is going to be equal to 1, right? Because this is unimodular. And if this is unimodular, I can also write it like this: z1 minus 2z2 mod is equal to mod of 2 minus z1 z2 conjugate, right? Because now this mod can be distributed in numerator and denominator I am taking on the right side. This can be written. Now what am I going to do? Now I am going to square both the sides. Whenever you see mod on both the sides, one simple approach, one suggested approach can be that you square on both the sides, some solution will come out. Now what terms do I have on the left and right side? Left side I have z1 minus 2z2 mod, and on the right side I have 2 minus z1 z2 conjugate mod. And I'm going to square on both the sides. So when I put square on the both sides, I quickly can think of one thing, that complex number multiplied with its conjugate result into square of mod of that complex number. Simply z into z conjugate is equal to square of mod of z. So here I have square of mod. That means I can write it like this. I can write z1 minus 2z2, the original complex number, multiplied with its conjugate. That means z1 minus 2z2 conjugate, whole conjugate, right? And this is going to be equal to 2 minus z1 z2 conjugate multiplied with conjugate of 2 minus z1 z2 conjugate. Now this part z1 minus 2z2, and this part, if I open the conjugate, it will be z1 conjugate minus 2 z2 conjugate. And on the right side, I'll have 2 minus z1 z2 conjugate multiplied with 2 conjugate will be 2 only minus z1 conjugate and z2 conjugate over conjugate. So it will be z2 back again. Now if I multiply the terms over here, z1, this will be z1 into z1 conjugate minus 2 into z1 into z2 conjugate minus 2 into z2 into z1 conjugate plus 4 z2 into z2 conjugate, right? And on the right side, I'm going to have 2 into 2, 4 minus 2 into z1 conjugate z2 minus 2 into z1 z2 conjugate plus z1 z2 conjugate multiplied with z1 conjugate z2. So now I can simply see minus 2 z1 z2 conjugate is over here also, and minus 2 z1 z2 conjugate is over here also. So I can cancel this. And minus of 2 z2 z1 conjugate is over here, and minus of 2 into z2 z1 conjugate is here also. So I can cancel this. So if I remove these terms, what am I left with? So let me write this once again. So now I'm only left with Z1 into Z1 conjugate plus 4 into Z2 into Z2 conjugate is equal to 4 plus Z1 Z2 conjugate multiplied with Z1 conjugate and Z2. So what this can be written as Z1 into Z1 into Z1 conjugate is going to be mod of Z1 whole square plus 4 into mod of Z2 whole square is equal to 4 plus Z1 into Z1 conjugate will be Z1 square and Z2 into Z2 conjugate will be Z2 mod square. So this is what I finally have. And if I closely look now, this is a square plus 4b square is equal to 4 plus a square into b square. If I factorize this, the factors are going to be mod of Z1 minus 4. Mod of Z1 square minus 4 will be one factor and 1 minus mod of Z2 square will be another factor, and this is going to be equal to 0. If I take all of this on one side, then these are going to be the two factors. Now either mod of Z2 square can be equal to 1, but if mod of Z2 square is equal to 1, this means that mod of Z2 is equal to 1. But what was written in the original question, that Z2 is not unimodular. So this case is not possible. We can only say that mod of Z1 square is equal to 4. This means that mod of Z1 is equal to 2. If mod of Z1 is equal to 2, then it's clear that the point Z1 lies on a circle of radius 2. Simply solved. So that's all from my side on this topic. Please don't forget to watch the complete playlist. The playlist link is in the description box. Still, if you have any more queries or suggestions, please feel free to reach out to us in the comment box. Thank you. Stay tuned with us.